from 2010 to 2016. His work focuses on the understanding of how materials and specific ore deposits affect water chemistry. Pete relies on his experience from the industry and academia to provide guidance for informed decision-making to minimize environmental risks. Pete?
Thank you. I feel like I should have a harmonica or something like that. Well, thank you for all of you for coming. Sorry that I wasn't able to get here sooner. The weather did not cooperate. But I really do appreciate the opportunity to speak. Okay, unidirectional. All right. So again, just thank you. Thank you for giving the opportunity to try to share some information that I've learned over the years, and I will start. So the objective for today is to just try to relay concepts that are related to management of waste rock and tailings. The ultimate goal is trying to minimize environmental risk. And I wanted to start with just discussing some of the terms that I'll be just using today. Waste rock is rock produced to access ore, and it can be unmineralized, or it could also be sub-ore grade rock as well. And then tailings are the byproduct of the milling process. So their milling separates ore minerals from non-ore minerals, and that tends to be a silt or a sand. So when we're comparing these two, when you consider waste rock, that's coarse, angular rock material. Tailings generally is silt or sand. And then I've included construction rock because a lot of the construction activities, whether it's building roads or foundation pads or drains, things that require rock or mineral, if they require rocks or mineralized materials, you might not want to use waste rock. So I think it's good to distinguish those two. So construction rock, waste rock, tailings. And I also think it's important to realize that each deposit is unique and geologically, and then also the location is specific to, has specific climate and hydrology. So while no deposit is no deposit is the same, and so when we're talking about, I'm going to spend a lot of time talking about Greens Creek. That's my, I have a lot of experience with that deposit. Some of the concepts apply to what we're dealing with here with this deposit, but others do not. So you can't just necessarily translate everything from one to the other. Each one is unique. Here's some photographs of those three different materials. The upper left is a sample of waste rock. It's been exposed for several years, so you can see some fracturing of the rock, but it's angular, coarse-grained. Down here we have tailings. This is the medium or dark gray material. The photograph doesn't maybe do justice to it, but it looks a lot like concrete actually when it's placed and dry. And then they're spreading rock over the top of that as an erosion and dust barrier. So that prevents erosion of the tailings and then also limits the amount of dust that material produces. And then the third is some construction rock that was imported. It actually brought up from barge from Seattle. The project required, yeah, it's kind of hard to imagine that we were importing rock to a mine in Southeast Alaska from Seattle. But the project really required a rock that was as inert as possible. And we wanted it to, the drains that this rock was used to construct, we really wanted to have that water be as good as we could get it. And oftentimes when you develop a quarry, particularly in Southeast Alaska, sometimes that rock has sulfide pyrite in it, or even, we were trying to limit the amount of carbonate that was in the rock. We didn't want to have carbonate alkalinity contributing to this particular drainage. So at great expense, barge loads of gravel came up from Seattle. So I think the ultimate goal for all of us in the room is just trying to understand how we can manage waste rock, tailings, and construction rock and how those materials can potentially affect water quality in the long term and the short term. It's a simple question, but a very complex answer and a lot to be discussed. I think when we talk about management of these materials, you want to think of it in terms of risk, managing risk. And risk has two components. It has the probability of occurrence or the likelihood of occurrence, and then also what are the potential consequences of that. I think a good example might be lightning, where the potential to be struck by lightning is low, but the consequences are high. If you go out in a thunderstorm and go climb a mountain and expose yourself to lightning, then you're increasing the probability of being struck by lightning, which increases the risk. In terms of materials, there's similar things. There's ways to try to minimize the likelihood of an occurrence if it's developing acidic drainage or even neutral drainage with metal concentration, high metal concentrations. There are things that the mining company can do to lower the likelihood of those consequences occurring. So that's, I think, just an important concept of how we're trying to manage risk. And then also, there's quite a bit of talk about acid mine drainage or acid rock drainage. And that's because acidic waters, whether they're natural or man-made, can have high metal concentrations. And so we put a lot of emphasis on acid rock drainage, acid mine drainage, but I think it's also important to look at the full spectrum of drainage, kind of regardless of pH, and that there can be neutral waters that are high in metals, there can be acidic waters that are low in metals. So we want to look at water quality as a whole and not necessarily focus just on acidic drainage. That said, because of the potential consequences of acidic drainage, that risk is there, and so there is quite a bit of emphasis on that. Okay, so talked about that you can have contaminants of concern in neutral drainage, and then one thing about neutral drainage is the water quality tends to improve with time as you consume reactive surface area, and some of those reactions go on. You generally tend to see an improvement in water quality over time, whereas if you have acid-generating material, sometimes you'll have an initial period where the water won't be too bad when you have neutralization reactions happening, but then ultimately, if the drainage becomes acidic, then the water quality can deteriorate. Not all acidic waters are of concern. If you go out to a peat muskeg, that water is actually acidic, usually pH of 4 or 5, but generally very dilute, low metal concentrations. Same with forest soils, water's coming from forest soils. And then also I just mentioned that we put the emphasis on the drainage from iron sulfides because the potential for generating acidic drainage can have significant consequences. To generate acidic drainage, you have to have the acid-forming reactions outpace acid-neutralizing reactions. So we've got this tug of war between two processes that are occurring, acid formation and acid neutralization. If you can limit the pace of acid generation, that helps that pull between those two, and you can minimize the likelihood of generating acid. That can be done by minimizing oxygen access. Pyrite oxidation, this formation of acidic drainage, is an oxidation reaction. You provide oxygen, the pyrite weathers or oxidizes and produces acid. So if you can cut down that oxygen source, you can limit the rate of oxidation and the rate of acid formation. I use the analogy of fire suppression. That's how you try to prevent a fire, is cut down the airflow, cut down the oxygen concentration. The materials can't burn, or at least they burn at a slower rate. And then also consider the physical characteristics of the material. You can push a lot more air through a coarse rock material than you can through a fine carbon or a fine tailings. So if it's a silt or a sand, it can't accept as much air as a coarse rock pile. So that will affect the rates of these reactions. And then also, you can limit oxidation in terms of depth of burial. the atmosphere has higher oxygen concentration and is depleted with depth. You can have oxygen consumption by oxidation of sulfides or organic material up near the surface. And then also saturation with water. We're in a very wet climate, and water is, if you fill the pores within that matrix, whether it's waste rock or tailings, with water, the migration of air through that is reduced to diffusion through water versus diffusion through air. And that is orders of magnitude slower through water than air. So that's a benefit of having a saturated material. Okay. This is the one chemistry slide. I cut many slides out of this presentation to try to keep it rolling, but I had to at least keep one. And so this is the tug of war between the two processes. Acid production, where we have pyrite, that's the iron sulfide in the rock, reacting with water and air to form sulfate, acid, and iron. So that's the key acid-forming reaction. And then acid neutralization would be the other side, where you've got calcite as a carbonate mineral reacting with the acid to form calcium and bicarbonate. The analogy would be if you have acid indigestion and you take Tums or Rolaids, you're using the Tums or Rolaids, which is a carbonate material, to neutralize the stomach acid. So that's that push and pull between those two things. Okay. So just some general concepts to provide. One thing you want to do is provide for management of these materials while also considering what those activities, how those activities will affect the watershed in terms of hydrology and chemistry. So you're looking at upslope diversion of waters, natural or synthetic liners, covers, and then also downslope collection. The company would like to focus on dust control, sediment control, and then tracking materials. You want to keep the materials that you're trying to contain within containment, and that's an area that is a good challenge for continuous improvement for the industry. And you want to design for closure. The decisions that you're making during operations, if you have somebody on the staff or preferably many people in the staff that is looking long-term, what is the outcome of the decision that I'm making today? How will that affect drainage long-term? And in the mining industry, often you tend to get a little focused on the short-term production, and you need somebody there saying, well, what is this decision today? How's that going to affect drainage? How's that going to affect closure? Those having somebody at the table while those decisions are being made is important. And it's also important to have the employees of the mine educated in these types of issues. And that's one thing that I've done many times throughout the years at Greens Creek is providing education to the truck drivers and the geologists and the miners about acid rock drainage and the environmental consequences of their daily jobs. And also having corporate buy-in. If you've got a company that really subscribes to that education and scientific method and understanding these processes, it goes a long way. And having a good water balance with associated flows and chemistries is really part of a good project, understanding how that water balance will change over the course of the operation. Okay. So I'd like to jump into characterizing the materials. So I've talked about waste rock and tailings, what they are, but you really have to have a fundamental understanding of how those individual materials will behave in a weathering environment. And this is a case where each mine is unique, each ore deposit is unique, so you have to do this with all of the materials from each independent ore deposit. So I'm just going to go through some examples of what to look for. In terms of mineralogy, you want to understand the chemical makeup of the rock. Talked about acid-base accounting. That's the balance between acid-forming minerals in the rock and acid-neutralizing minerals in the rock. So acid-forming minerals would be primarily pyrite and pyrrhotite. They're iron sulfides. And then you have acid neutralizing rocks, minerals like calcite, dolomite, and some silicates. And so the relative balance or relative proportions of those two types of minerals will affect whether the rock is potentially acid generating or potentially acid neutralizing. And then there's several minerals that don't actually participate in that back and forth between those two processes. This image is really hard to see with this illumination, but these are pyrite grains in transmitted light. So you can see some pyrite here and here. They're dark. This material is dolomite, so that's a carbonate. So we're looking at the balance between these mineral grains and this one. It's a lot better when you're looking down the tube of a microscope with good illumination that you're able to use this. It's just not the presentation with this lighting just doesn't do justice. So I won't spend too much time on that. Physical characteristics are also equally as important to what is actually present in the rock. So we're interested in the proportion of the various minerals, and will the rock hold together? Is there a lot of quartz in it, or is it perhaps more micaceous, where it might open up like a book when it weathers, exposing more of its mineral content? Is it foliated? In terms of the foliation would be just a series of shear planes that act like pages of a book. And then particle size and also crystal size. So the difference between tailings and waste rock, that would be particle sizes, but then also how are the crystals? Are they fine grained or are they coarse grained? Fine grained material tends to be more reactive than coarse grained. And then also what's the crystal structure? Are the crystals nice, well formed, or are they kind of grubby and amorphous? Or typically the better formed the crystals are, the less reactive they are. I've got a slide coming up. Hopefully that will be illuminated well enough to show you that. And then also, I think the key point is that the minerals in the rock are controlling the chemistry of the water. And so the solubility of those minerals at a given pH is going to affect what the water that contacts them will pick up. And ultimately, so you have the primary minerals are in the rock, like pyrite, quartz, carbonate, but then as those materials weather, you produce secondary salts, secondary minerals, and those are really what are controlling the chemistry of the water. It's the buildup and then dissolution of those salts that controls the water compositions. Okay, so these are some more micrographs of some of the minerals. So this is reflected light. So we've got a piece of rock that's been cut very thin and polished, and we're shining light down on it, and it's reflecting back at you. And you can see that these pyrite grains here, some of them are well-formed crystals like this, but then there's several here all along this foliation plane, and they don't actually have good crystal structure. So if that rock breaks along that foliation plane, then those pieces of pyrite could be exposed to oxidation. And that's good to know. So you look at the rock, if the pyrite is along foliation and it breaks along those foliation planes, that rock would be more susceptible to these oxidation reactions than one where the pyrite's disseminated within the ground mass. And this is a case where this is a pyrite crystal that is very well formed. So this would be much less reactive than this pyrite framboid here. This golf ball looking thing, they tend to be very reactive. So understanding what the crystal makeup of the minerals is also important. Okay. And here we've got some reactive salts. So these are what are controlling the actual drainage compositions of these salts. We've got sulfate salts here. There's some resorbed sulfur, native sulfur, and then hairs of sulfate kind of growing off it looks like, in some cases it would look like fuzz on the rock, but it just, I wanted to get the sense that these are really what are controlling water compositions. Okay? So we've talked about the materials in the rock, their physical characteristics, but then how do they weather? And to do this, you develop testing of the materials to understand how they're going to perform. Some of that's done in the labs. Also, you can have it done in the field. Ultimately, you'd like to have lab and field, and then also natural analogs if you can, where you're actually sampling material that's been exposed to weathering to get a sense for what the chemistry will be. And so that's actually what's going on here. These are cells, test cells that are outside in the weather, and we're able to get a sense for what the chemistry is coming off of that. And I really can't stress enough the importance of trying to involve student research and university research in these projects. I think it really is a great way to get some good science done, peer-reviewed or committee-reviewed material, pretty cost-effective, and then also just the detail is actually better than you can get by in-house work or even consulting. So Greens Creek has done really well with trying to incorporate student projects into their studies, and that's actually what was going on here. This was a study of adding carbon to the tailings to try to improve water quality, and I was a PhD student from the University of Waterloo. Okay. So let's talk about some of the ways to try to dispose of waste rock. What can we do to get this material placed in a way that minimizes those environmental risks? Can you segregate the different rock classes? If you have potentially acid-generating rock and potentially acid-neutralizing rock, can you use the acid-neutralizing rock to encapsulate the potentially acid-generating? Can you keep the potentially acid-generating rock underground if it's an underground mine? Utilizing segregation or classification of the rock to achieve minimizing the potential for acid generation. And then also, would the site be deposited at angle of repose? That often happens with a mine dump where they'll dump off a tip face, similar to what we're seeing here in a stockpile. This is just a small stockpile of rock, but it shows the same principle. If you drop material off the top, the coarse material rolls to the bottom, and then the fines kind of are deposited up on the slope. This actually allows air to be brought in at the base of the dump and brings air in and can promote oxidation. Waste rock dumps actually breathe. During the winter months, when the interior of the deposit, the dump is warm, air will be pulled in from the bottom and up through the material. And then in the summertime, when the interior of the dump is cooler than the surrounding area, the reverse process happens. The cool air comes down and flows out the bottom. So these things are bringing in air in and out. And so if you can minimize that airflow by maybe not having a big rubble zone at the bottom, you can cut down on those reactions. Okay. So I talked about encapsulation of material. You could also blend if you have enough material to get a mix that is acid neutral. If you don't, then encapsulation might be a better method where you're just utilizing that acid neutralizing material on the outer surface of a dump. Co-disposal, if you mix the coarse material with the fine-grained material of tailings, you can limit the pore size, and so that would limit the amount of air that can flow into those materials. Site selection is really important in terms of finding a site that's stable, enables good containment of the drainage, and that you have room for expansion, and then also you consider potential hazards like earthquakes, landslides, avalanches. Another concept is that cutoff grade affects the proportion of waste rock versus ore, and so it is a product of the market price and then also the cost to produce. So if the market price is high, then you can affordably or cost effectively produce more ore, which then reduces your relative waste rock. And then the opposite would be true too. If the market price goes down, then more would end up being as waste. So the amount of waste produced can be dictated by market prices. This is just an example of co-disposal where the waste rock was mixed with the tailings. Okay. This is Greens Creek's waste rock site. It's unusual relative to many that you might see in the world. It was built starting in 1995 from the bottom. It was built from the bottom up in sub-horizontal lifts, so not angle of repose off a tip face. So we didn't have that size sorting that I was just discussing. And it was built at a 3-to-1 slope from the bottom up. So it is at a reclamation grade. Come right over the top of this with a cover. And then this is natural vegetation, volunteer vegetation that's grown in over those intervening years. So this is not a final cover. It's just an interim vegetation that's occurred while the waste site has been exposed. Okay. So for tailings, the primary goal would be to try to backfill as much of the tailings as possible. And that can be done either by dry cemented backfill or potentially paste. Paste backfill is where the material has enough moisture that it can be pumped, but once it's pumped into the stope, it doesn't separate, the water and the tailings don't separate. 5 minutes, okay. And that's a really effective way to fill up stopes. And that's actually part of the mining method, cut and fill mining method, where you might come in and mine a stope out and then backfill that stope with cemented tailings and then come in and mine the next layer out and work your way up, replacing the mined out ore with cemented or paste tailings. It's a very efficient way of mining, but also retaining as much of that material underground as possible. When we think about different types of tailings deposits or tailings facilities, you can have the traditional slurry type tailings where you have a dam and then the slurry is pumped in behind that dam. Or in case of Greens Creek, they went with the dry stack where they have a pile of tailings that has been dewatered and you don't have, the material isn't placed behind a dam. You're relying on that dewatered, compacted tailings to have its own stability, not the stability of a berm around the outside of traditionally slurry deposited tailings. And there are pros and cons to both of these. So you can't say that one is good for all. And there's pros and cons, and each facility or each operation has to determine what's best for it. Some things to consider are that traditional slurry-type tailings deposits are usually much larger in footprint. That will affect the amount of disturbance, but also the water capture area. If it needs to be covered, the amount of cover material that would be needed. Stability it would be different. You're relying on the stability of the berm. And then also capital costs tend to be higher, whereas the dry stack tailings, the operational costs are much higher because you're utilizing trucks and lots of heavy equipment, dewatering equipment, it has improved stability. It has a smaller footprint, and some of the other challenges with it is in a wet climate, it is difficult to achieve that density. It's a struggle. So it's not necessarily good for everybody, and that there aren't. I think it's important to realize that there are challenges associated with it. Another one would be sediment disposal. With a traditional tailings pond, there's always a place to put sludgy sediments, and if you've got a dry stack tailings pile, it's harder to deal with those. Okay. This is the Greens Creek tailings pile. It's at a 3-to-1 slope. This is an interim cover of peat that was placed over the tailings to, again, eliminate or minimize the potential for erosion and dust, but it also acts as a good growth medium. And it's also an oxygen consuming layer. So oxygen isn't actually getting into the tailings below this, it's being consumed by the peat. Okay. And then as we look toward closure, we're thinking about closure the whole time, but as you get, what are some of the components of developing a closure plan and a cost estimate for closure that are important? Primarily assessing the water quality and coming up with an assessment of what that water quality will be like. So that's where you're relying on your water balance and understanding chemistry, understanding the materials, and these methods that you've used to try to minimize those acid-forming, acid-neutralizing reactions. And then in terms of a reclamation cover, the design of that cover depends on whether or not the material is potentially acid-generated or not. If it is, then you're really probably going to want to focus on oxygen exclusion. If it's not, then you might be able to allow oxygen in, but then you'd be focusing more on trying to minimize the water percolation. Are you going to try to use natural materials or synthetic materials? So plastics and liners or natural barrier layers. And then some of the things that you want to consider when making that decision is what's the complexity of the cover and how easy would it be to repair in the event of say, an earthquake or a flood. Okay. And this is an example of a soil cover. So this is using the natural materials. And we've got 2 feet of growth medium on top of a 10-inch drain layer, and then a 2 feet of compacted barrier layer on top of another drain layer, and then the waste rock. And the key to this cover, it's an oxygen exclusion cover, is maintaining saturation in this barrier layer. If those pores are filled with water, the oxygen would have to diffuse through that 2-foot layer of water, as opposed to if it was not, if those pores were filled with air, the diffusion rate would be much, much quicker. If you can give me just a little bit more time, I'm almost done. 1 minute. So this is the example of that cover. It's been exposed for about 17 years. It was built in 2000, and so that just wanted to give you an example of some of the natural vegetation that's volunteered on that surface. It was hydroseeded in 2001, and then that's how it's developed since then. Okay. I can talk quite a bit about water treatment, but I'm running out of time, so I might save that for questions. But utilizing a good state-of-the-art high-density sludge, this is a high-density sludge plant, really is another method of trying to protect minimize that environmental risk. If you've got good water treatment options available and technology to treat water, that's another way to help protect the downstream drainages. Okay? And there are lots of things you would consider when developing water treatment for closure. Gravity versus pump systems, batch versus full-time pumping, low maintenance versus active, and then care and maintenance. Ultimately, and I'm sure Kyle will talk about this right up next, but you want to have a good bond, good reclamation bond, that these costs are captured, and that ultimately the mining company is on the hook for those costs and not the regulatory agencies or the public. So thank you very much. Appreciate it.
Thank you. So I know that's a lot of information. It's very great. We catch the ferry at 4, and we still want to have them available for questions up here. Our next speaker is Kyle Moselle. He's an Associate Director for Alaska Department of Natural Resources. He's based in Juneau. He's responsible for leading the state's large mine permitting team. He currently coordinates permitting for 5 operating mines, 3 exploration projects in Alaska. And he's got lots of other experience, but I'm going to move us along here, and we get Kyle for about a half hour to talk about his complicated but interesting information.
There you go.
Thank you. So I'm Kyle Moselle. I apologize that I'm just now coming into the forum. I've been trying to get here for a few days. Finally got here on the Trusty Ferry. So I don't have the benefit of having heard the previous presentations or the discussion that's taken place, and so that's something I would have benefited from. So I'm sorry that I wasn't here earlier to get that, and so I'll try to move through my topic, which is the state's coordinated permitting process, and I'll be here through tomorrow. So if folks want to take my card, I'd be happy to hand them out and follow up either later tonight or when it's convenient for you individually. So, this is my only slide. It's a good one though, it's complicated. So the large mine permit team, it's a networked program. I work for an office called Office of Project Management and Permitting. It's within the Department of Natural Resources. And it's not a permitting office. No permit from my office is needed for mining. What we do, what OPMP does, what I do as a large project coordinator, is we facilitate the various permitting process that a mine is required to go through at the state level. We also, it's meant for public information purposes. It's meant to help with discussion about this, which a lot of people don't like to sit for an hour and have me talk to them about permitting. It's really boring. I get that. And so what I've done is I've developed this diagram over the last couple of years. I was here 2 years ago at the public meeting that was held then, and that was the first meeting I think I developed it. So I developed this as a visual aid for myself and for the public as a result of coming here to Haines a couple years ago, and I've been using it since. I welcome any feedback on how you think I might improve it. But you start in the middle here. So this is Office of Project Management and Permitting. That's the office I work for. And then you work outward. And so I think the best way to do this is talk about how things actually happen as a sequence of events. A mine company, when they are ready to submit an application to get all the necessary approvals to develop an operating mine, by that point they've been exploring the project for a long time. It's not unheard of to have them explore for 8 or 10 years before submitting an application for development. But that application comes in, and it typically will come in to the lead federal agency. And if we're talking about the Palmer project right now, it's located on federal mining claims. So the Bureau of Land Management would be the lead federal agency if an application was submitted today to develop the Palmer project into an operating mine. So that kicks off the NEPA process, National Environmental Policy Act. That's the environmental review. I'm not a federal agency representative, but my understanding of the goal of NEPA is to describe all of the reasonable, foreseeable impacts to the human environment from a specific proposed activity. That includes cumulative effects with all known past, present, and future activities in that same region, watershed, usually. So scoping, you've probably heard that term before. They put it out. They want your initial input from the public. They scope the project. They develop a purpose and needs statement. Ultimately, they work through the NEPA process, and the lead federal agency will produce a draft environmental impact statement if there's going to be significant effects. If the effects are not significant, which is defined in federal law, they can do an environmental assessment rather than an environmental impact statement. But all those are the details I'm probably not going to get into today. With this diagram, this dotted line here, an advisory role. So the large mine permit team can plug into the federal process. And that's what I'm trying to show here. How we do that is called cooperating agency status. It's allowed for under National Environmental Policy Act. And we will typically take advantage of that. We, the state of Alaska, will typically take advantage of that. And the large mine permit team is the avenue to operationalize that. So we plug in typically as a cooperating agency, and then this team will participate with the federal agencies through their environmental review process. Towards the end of the environmental review process, usually around the draft impact assessment, draft environmental impact statement phase, we have received the application at the same time. It's just we don't need to do a lot with it. The federal agencies have their part well ahead of where we really start to take a serious look at the project, because it does typically change through the NEPA process. Once a draft environmental impact statement is out, there's a preferred or a proposed alternative that is kind of rising to the top of all the alternatives being evaluated. That's when the state agencies start to really take a look at that alternative, and they start to develop a concept of how that proposed or preferred alternative may comply with state laws and regulations. And when I talk about the permitting process, that's the outcome of the state permitting process, is compliance. Okay, so if a proposed activity complies with state laws and state regulations, then it's permittable. So that's what we're trying to achieve. We're trying to check to see if the proposed activities comply with state laws. Now, individually, how that works is through each of the agencies listed here. Before I get into the permits and authorizations that are moving outward from the center of this diagram, I would just want to point out two other advisory roles. Department of Law, there's no authorization that anyone needs from Department of Law. Their role is internal. It's advisory, which is represented by this dashed red line. They advise all of these agencies of legal understanding of their individual regulatory, statutory authorizations. And then Department of Revenue, this is Alaska Department of Revenue here. They have an advisory role in the financial assurances, or what we often refer to as bonding, okay? So law advises the agencies that participate in the large mine permit team, and revenue advises DNR and DEC on the financial assurances that we have to approve for the reclamation piece of the project. The other agencies are independent agencies. They have their own strict regulatory, statutory authorities, and they need to consider the activities within those authorities. Without the limpet process, each agency would look at the project individually. Some require public notice of their process and draft proposals or permits, others don't. What the large mine permit team provides is a team approach for us to take a look at the project together, and that I believe benefits the state agencies and the public. It reduces duplication of effort. It can be more. We catch conflicts in the project or non-compliance with state laws quicker, I believe, and we can also be more inventive in the ways that we solve those challenges or solve those problems. The design features that we can make recommendations for, I think, are better informed through this team approach than single agency efforts. So now getting into the authorizations. The other thing that I think is really important here are the yellow and red borders that I've put on here. The red borders mean that there is a statutory or regulatory requirement for the agency to publicly notice that authorization prior to making a final determination. The yellow boxes means that the agencies typically still push them out for public notice and take public comment on them, but they're not strictly required to under the state law to do that. They do it as a courtesy. So we refer to those often as courtesy public notices. Okay? There's a handout that I think was circulated yesterday that this represents. It's a visual representation of it. And so if people didn't get it, it's called Permitting Large Mines and Mine Projects in Alaska. It's I guess a 4-page front and back document. It's available on our website as well. And this is the visual representation of that. So, I mean, I can pretty much stop there. Going further would be going into individual authorizations. If I were to do that a little bit, I'd probably call out this avenue here that goes up and down, the mine reclamation closure plan, the plan of operations, the mill site lease, financial assurance, waste management permit. Those tend to be the permits that drive the design of a project, and those tend to be the ones that are spent the most time on by the agencies. So,
All right, we have a big pile for Kyle here, so including some questions from yesterday. So I think we'll start with a question for Kyle. There was if a request is made to Constantine to share water quality test results from artesian wells, like 3 artesian wells in the valley, are they required to share this information?
okay. Any information that's shared with the state agencies, unless it fits under a particular statute, but I don't remember off the top of my head what the number of the statute is, unless it's considered confidential or trade secret or financial information, all of those things are considered confidential. Anything else is part of the public record if the agency receives it, and if you do a state records request, or if anyone does a state records request, the agency would provide that information. So that's the general answer. If you're talking about water quality for, what did you say, an artesian drill?
Yeah, artesian flow from, I see drill wells.
At what point in the project are you talking about? During exploration or during operation?
I think yesterday we saw instances of from exploration, in particular artesian wells that
Okay.
exist now in the drilling in the Chilkat Valley.
Okay, so an artesian well during the exploration phase of the project, it's not subject to water quality standards. So the operator is not required to provide reporting data of water quality. I guess that's the answer for that scenario.
Okay. So, one quick response on that, and then
I'll make a quick response just so we can move on to more questions because I know there's a lot here. But with respect to all of the data that we're collecting, there's a lot of data that we're always collecting on a variety of different topics, and a lot of it does become public at some point through the permitting process. And so, for example, for our last environmental assessment, we made a lot of our data on wildlife data, fisheries data, water quality data, rock geochemistry data. That was all provided in the environmental assessment, or with our plan of operations and dependencies with environmental data, with all of the collection methods, the analytical methods, the quality control results, so that everyone had that information to help in the analysis of the project that was being proposed. And so that's what we're always doing, is continuing to collect data, and it becomes part of the permitting process once we know what we want to be really proposing. And so for us, there's a lot of data that is proprietary during certain periods where we need to collect it for certain reasons while we're contemplating things. And then once we gather a body of knowledge, it's easy for individual data sets to be taken out of context or to be not appropriately considered with other factors. And so we like to put that data together in context with all of the information so that it can be evaluated in a nice comprehensive discussion. And so there'll be periodic times where there's a lot of data that comes out, and we're happy to walk through that together.
thank you. Here's a question for Jacinda. Do you think over the long term mining has been or will be beneficial to your community? Why or why not?
I think that there's a lot of mining in our community, in the entire territory, and that includes placer, that includes exploration, that includes hard rock mining. And when we think about balancing our way of life and the traditional economy that we depend on for the land, to be able to hunt, to be able to fish, to be able to live a way that we are connected to the land, mining has severely impacted that to the point where we are basically locked out in most of those places now, and we have to go farther and farther away. One of the key areas where we were able to go was where the Mount Holly disaster happened. So we have basically been pushed out. We can't fish our river anymore. Our entire watershed, the Fraser watershed, has been impacted by industrial and small-scale mining practices. So we've been pushed to the point where we are not even able to enjoy our land in the same way and live our lives in the same way anymore. So I would say that it has, over the last 200 years, has come to a critical breaking point, which was embodied by the disaster. So I would say no, it is long-term for my bloodline. It hasn't been beneficial for us.
Thanks, Jacinda. Okay, we're still working on the microphone levels, so pardon and apologies for that, but we're working on. This is a question for Pete. Okay, Pete, what do you think are the most significant environmental risks to the watershed from this potential mine? And they're talking about, obviously, the Constantine or the Palmer project. And I suppose you could talk about the exploration stage or the long-term stage, but it wasn't defined, but that's the question.
Sure. Well, I do not have an intimate knowledge of the Palmer project's chemistry to the level that I do at Greens Creek. So I got to say that I would be talking from a point of disadvantage there. But just in general, in terms of my presentation, I think managing materials, waste rock, and tailings to try to prevent or minimize acid formation that's the key. You really want to get that one right. The other things that I discussed in terms of dust, sediment, those I think would be secondary. So if I were in a position to really try to make a difference and make sure that things are done properly, it's minimizing the potential for generating acid rain. I hope that answers the question.
That might, I don't know. Thanks a lot for that, Pete. We're going to keep moving along here. Jim. So, what benefits has Greens Creek brought to Angoon, the only town on the island? Admiralty, obviously.
Don't have the latest data on the number of Angoon residents that are employed at the mine, but Greens Creek has had a pretty extensive outreach program for the folks in Angoon, and there still are folks that reside in Angoon that are employed at the mine. At one point there was 4 or 5 local residents employed at the mine. I don't know what the number is today.
Thank you. Another one for Kyle. The Constantine deposit has been compared to Greens Creek's, but Greens Creek has had many problems and violations. Can any of can you comment on the degrading of Hawk Inlet as an impaired water body, and the community of Angoon having to give up the area for fishing and hunting?
Wow. So these are tough questions because there's a lot to talk about with each one. And I'm not going to be able to cover everything, so forgive me. So first, the classification of Hawk Inlet. There's 2 locations in Hawk Inlet that DEC has added to their impaired water body list. There's I think it's around a 1/4 acre size at the loading dock facility for Greens Creek. And then there's another about, I think, 1/4 acre spot that is up at the head of the bay that is thought to be associated with a legacy mine that's been closed for generations. The rest of Hawk Inlet is not classified as a degraded water body. Also, there was a recent study called the Total Maximum Daily Load that the EPA and DEC completed this past summer for Hawk Inlet, where they did evaluate the entire water body for sources of pollution, and they found, that report found that there was not a connection beyond the shiploading dock location that it traces back to the operation of the mine. And so that was a known discharge of concentrate that happened at that site back in '89, I believe it was. And so that's well documented now in the Total Maximum Daily Load, the TMDL, and the cleanup of that site. And then what was called for was continued monitoring of that site to see natural attenuation of that material. That's probably where I'll tie it off, I guess. Although I'm sure there's other components to that of that question I didn't get to.
I think you kind of covered it, just the impacts on fishing and hunting.
Okay, the impacts of fishing and hunting. There was a notice from the community of Angoon and an environmental group, Friends of Admiralty Island, that provided data to the state of Alaska that would suggest that certain critters collected in Hawk Inlet were being impacted by metal concentrations. That was evaluated by both DEC and the Department of Health and Social Services. Health and Social Services responded in writing to Cancun Community Association and the Mayor of Cancun with a detailed analysis of that data, and found that the levels were within human consumption for all of the critters except for two of the components of a single seal that was collected. And so they provided a consumption advisory for consumption of seals to the community of Cancun to educate them on, or I mean that sounds bad, not to educate them, but really to explain to them what levels they should be considering for consuming of seals from that area. And it was broken down by whether male, female, child, woman of childbearing age, those types of things. So it was a very detailed response. And then we also went out to the community of Cancun and met with the Cancun Community Association and explained that information and had a meeting with them.
Thank you. On Greens Creek as well, Pete. Greens Creek EIS predicts peak acid mine drainage in the tailings after 200 years. How will you treat that water and who will do it?
So the prediction for water quality is determined that it would be likely that long-term water treatment is necessary, and so that is part of their reclamation plan. It's part of their cost estimate, and they've done a detailed analysis of what it would take to treat water at 200 years, and that is factored into the bond calculation, where they put money aside for that treatment. So that's what the very tail end of my presentation said. There's a mechanism for bonding, and that's the number that you want to get right, so that the company is on the hook for that. So the company will be paying for that treatment.
All right, thanks for that. Here's a question for Jim Calvin. Jim, with 2 active mines and the millions of taxes paid, why has Juneau had such a difficult time balancing their budget recently?
Well, I would say one has nothing to do with the other, like all local governments, state governments, federal governments, they spend the money they have and end up having challenges balancing the budget. I think Juneau in particular is in the decline in sales tax revenues that are challenging the city manager and the assembly. But again, no connection between taxes generated by the mines and the challenges that the city generally has associated with balancing the budget. The truth is that the revenue that Main Street generates and Kensington generate directly for the mine in terms of those property tax revenues, $3.1 million a year, plus the property tax and sales tax revenues that the mine-related population generate. Those revenues far exceed the costs of services that the city of Berwick provides to the mine. They really don't provide any services to the mines. They go off the road system and are taxed at the property tax rate accordingly. So really the services that the city of Berwick provides that's related to the mine, at least to the mine-related population. And so on a per capita basis, the amount of revenue that mine-related population generates is far above any other commercial activity in Juneau. So in that respect, the revenues are actually helping the city of Berwick with its budget challenges. I think I answered that question.
Yeah, I think I understood what you said.
Jacinda, the next question is for you. I'm just going to read it as it's written, so it's a little bit of a paragraph here. There was mention of traffic and transportation today as a socioeconomic benefit. Could you please address the changes in traffic we could expect, both out the highway, in and around town, and in the port for a hypothetical mine project? Please describe in detail with the kind of vehicles that are used for this kind of thing, transporting ore, minerals, people, and supplies.
What we've seen in our community, we have a lot of So you have the transport trucks, the ore trucks that are transporting from the mine site down to Vancouver is where they're taking it out of the port, out of our territory. And you usually have like 2 containers full of ore that's covered that are being hauled out. A lot of the roads in and out of the mine site and on the highway, the roads are kind of narrow. There's a lot of hills. We have full winters as well. And it's a long distance. And along a lot of the pathways, we have a lot of creeks, we have a lot of water in our territory. And a lot of times that's where you're going to find a lot of gold, and it has to do with the whole makeup of our area. One winter we had one of those concentrate trucks tip over into the creek, and it was basically vacuumed up without any notification to anybody until it had been done, so nobody could go down on site. We had another truck going from a different mine that was hauling, I think it was fertilizer that had dumped over and was at risk of an explosion because of what it was transporting. So the entire community along the highway had to be evacuated for 24 hours before they could have that cleaned up and secured. And during those spills, the highway traffic was rerouted through our small community. We went for a drive the other day up to Cluckwan, and our community road is about the same width of the road through Cluckwan, with houses on both sides of the road. And we had traffic going through there for 24 hours off the main highway, and there were several accidents along the way. We had electrical lines and telephone systems down because of the accidents. We had interruptions through that because of those accidents. And then the traffic going through our community were like great big pickup trucks, big crummy trucks. You've got the going back and forth, running materials to the mine, running fuel trucks with tiny tanks on the back, running supplies. Because the mine is in a more rural area, everything has to be trucked in. So everything from laundry to catering to fuel to getting the ore out, those are the types of things. And then along the highways, you'll see when they're bringing in new equipment, they'll be coming in piece by piece because it's so big. And for anybody who's never been on a mine site, it's really hard to understand the scale of how big things are on a mine site. So they'll have to bring it in on these great big flatbeds. So, the range can be from a 1-ton crummy truck to these, really large-scale vehicles that are coming in, bringing in materials where they have to assemble the machinery on site. So the range is quite big.
Thank you. It sounds like these things may compare to our valley here. Kyle. Is it possible for a community to deny the development and operation of a mine?
I think it would depend on what authorities they have in their municipal code. Some municipals and boroughs have passed ordinances that regulate mining activities. I'm more familiar with Juneau than I am Haines, but Juneau has a mining code, and Kensington and Grange Creek are both within the incorporated borough of Juneau, and they have to adhere to the mining code as with anyone else doing mining activities around Juneau. And so I think the answer to that is in the mining code for a particular community. The way the state permits are written is that, let's say we give a reclamation plan approval. That's one of the major authorizations that Department of Natural Resources provides a mine company. There's boilerplate language in all the state permits, or major ones that say that they're still, the mine operator still must obtain all required federal, state, and local authorizations. So a federal authorization doesn't supersede a state authorization. A state authorization doesn't supersede a local authorization. They're all required. A typical mine has to get 100 individual authorizations is not unheard of for an operating mine to secure before they can put the first shovel on the ground and start digging a hole or making an adit.
Okay, thanks. Here's one. We'll start with Pete, and then I'm going to offer Kendra an opportunity to pipe in on this because it is for Kendra and Pete. So, even if fish return to a river after mining waste is accidentally released, will those fish ever be safe to eat? And there's a parenthesis here. In Montana, advisory notices cover a 100-mile stretch of river 100 years after copper discharge, warning humans not to consume fish. That's on the asker's mind. So will it ever be safe to eat the fish even after a accidental release, mine waste release?
I am not a fisheries biologist. I'm a geochemist, so I am going to defer on that regard. But also, I do want to stress the note that each individual mining project has chemical or has materials, waste rock, tailings that could potentially be, if they were spilled, that are unique. So you can't say that the spillage of a material from one mine would be the same as of another. So there's a whole range of potential consequences of the material based on what I just spoke about earlier today. All of those things factored in would determine what the long-term impact on that ecosystem would be. So it's a case-by-case basis, but it's in terms of the biological effects. I'm going to defer to Kendra. Thanks.
Yeah, so the short answer is yes, over time, with the exception of mercury, which will never, depending on concentrations in general, that will never be safe for eating, and that's been shown over and over in the western United States. It's generally going to depend on not only on the trace element or chemical, but on the bottom, the river bottom or stream bottom. If it tends to be gravel, cobble, oxygenated, a lot of that stuff will continue to flush out with every storm and go further and further downstream and dilute out. If it's organic material, still slow moving, that can tend to stay for a very long time. So, and when I say eventually, it can be safe. Yeah, it's going to be safe for people to eat a lot sooner than it's going to be safe for fish to live in general with the spill. Yeah, and over time can mean over a series of years, or it could mean a series of hundreds of years. So it really depends on the chemical and the stream environment.
Thank you. I have a question for Jim. How do you account for the economic impact associated with degrading water quality?
Well, an economist would look at it from a fisheries perspective, for example, by looking at what effects there might have been on the commercial fisheries harvest, if there had been some decline in the harvest. Same, you could, to the extent you could measure some change in the subsistence harvest or personal use harvest, you can place some dollar values on that and understand what the economic consequences are, at least near term, and then continue to track how, to the extent that you can connect an incident of decline in water quality with the mining operation and other changes in the environment. You can certainly quantify the economic impact of an incident. We'll certainly be watching Mount Polly closely, as I think next summer will be the first year that for the return of the stock that was spawning on the summer of the accident, and so we'll be watching closely to see what the socket returns are in Fraser River. So again, you look for opportunities to measure things as economists do.
Thanks, Jim. Here's one, I think, for Joe again, and then Kendra, you might have something to say about this. You do have some background in the...
Can I just add something really briefly?
Oh, go ahead, you said that.
When we're talking about degradations to water coming from an Indigenous perspective and what the impacts on the economy, we're talking about not only to what the industrial dollar figure is, but how does that play out over time in terms of way of life? How does that play out over time in terms of health? What we've seen in likely where this disaster has happened, since the mine was built coincidentally, because we we can directly correlate it to the mine, is the increase in cancer and the increase in illnesses in that area specifically. And so there are a lot of things that can be directly pinned on a specific operation, but there are a lot of different stories of how the water is impacting your quality of life, and how do you measure that if there's no dollar figure. And I think that thinking outside of dollar figures, when we're talking about economic impact, how that collectively impacts your quality of life also needs to be considered, even if there's no specific dollar amount. Some of it is just, you can't put a dollar amount on it.
Good point. Thanks for adding that, Jacinda. Okay, Pete, we'll start with you. If Kendra if she's comfortable or has anything to add, she'll let us know. Pete, can you explain where covers, because you touched on cover material, might be needed at an underground mine like Palmer is proposing?
Sure. So covers would be necessary if the materials that are produced would affect water quality to the point where it wouldn't meet a water quality standard. And so I mentioned a couple of different types of objectives that you would get from a cover system. If you're trying to cover potentially acid-generating material and you really want to limit the amount of oxygen coming through, then you would design a cover that would achieve that purpose. If the material just doesn't need to exclude oxygen, but you just need to cut down on the rate of flow through that so that the amount of water that would be emanating from that is less or of better water quality, then the cover might be designed differently. So it would depend again on the material types. But the material type would dictate if and what kind of cover would be necessary.
I would say there's different situations in which you need covers. So some of those are going to be short-term, like if you have an ore stockpile, and you may need to cover some of those if they're not ready for the mill, if they're going to have to sit off to the side for a while, and those might be covers and liners. And then the kind that Pete's talking about is your long-term. This is the permanent material that will stay on the surface. So that would probably be your waste rock, I guess, in this situation. Any material that couldn't get underground for whatever reason. So there certainly are a lot of things you can do to cover up ore stockpiles, even soil stockpiles, so you don't get sediment washing down, things like that. So there's different covers designed for different situations.
Thank you. That sounds good. I am going to combine or join two questions here. One asks, and this is for Kyle, does mining company bonding cover catastrophic mine failure? And if not, who pays for cleanup in Alaska? And the second person asks, does Alaska mandate disaster plans for mines?
Okay, so we get this question a lot. Bonding or financial assurance is the requirement to demonstrate proof of financial responsibility. All those are the same thing. We call them bonding. It's required under a couple different sections within DNR, dam safety being one, mine reclamation being the other, and it's also required under DEC's waste management statutes and regulations. And it covers the planned closure and reclamation and long-term or near-term both monitoring post-closure and reclamation. To answer the question, the bonding is not expected to cover catastrophic or unforeseen or failure-type scenarios. And again, remember I said that permitting is about compliance with state laws. And so it's not permittable to have a failure of an engineering facility. It's not permittable to have a catastrophic release of waste. Those things are not permittable. And so it would make logical sense that the permits wouldn't anticipate those things. And so if they were to happen, then it is a non-compliance situation. It's a permit violation when those things happen. And it is the ultimate responsibility of the mining company to be strictly liable for those things. And so that would include cleanup, that would account for restoration, long-term monitoring. You know, what we're seeing essentially following Mount Poly. It's a different jurisdiction, different laws, but functionally it fell to the mine company to correct that violation situation. Now, I think just to take the question a step further, if the mine company is unable to meet those situations, there are avenues for the state to follow as far as seeking compensation for those impacts. It becomes essentially a legal pursuit that the state has against the responsible party. For as long as they're a responsible party, they're always a responsible party. And so, I think to get to the point where maybe the person's getting at in that question is, if the mine company has been bankrupt through the whole situation, if money has been spent and there's still cleanup needed, I guess the last stop on the whole rail is the public has to bear the cost of that cleanup if it still is outstanding and the mine company is no longer in existence.
And not so much a requirement for a disaster plan per se.
So disaster plan, I mean, that's just such a broad statement. There are requirements for emergency response plans. Those are in every mine plan of operation. There's going to be specific plans for operation and maintenance of all of the approved facilities, and those plans will include contingencies if certain components of those are not performing to standard. So yes, planning and contingency plans, I won't call them catastrophic or what the term you use, but contingency planning is a huge component of the plan of operations process.
Jacinda, this one's for you. It references your presentation this morning. In your presentation, you noted 30,000 pages of studies, which is too much information for the average person to digest. What do you see as a balance for an adequate environmental study of a proposed development in a way the public can properly understand?
I think that I was speaking with a scientist once about how we were going to deal with all of this information and to understand what these processes were. And he said, you know, he goes, one tactic that we're seeing is we were dealing with Taseko Mines, who operates in our territory, and they're very aggressive and very litigious, and they've been really difficult. And he said one thing that we've had to, that we've noticed is that if it's straightforward, you can explain it very simply. But it's when things get really complicated and there's a lot of information to try to explain something. If it's not something simple, it's like, what are they not wanting you to know? And so trying to digest all of this information, I think there's a lot of processes that can be explained quite simply of what it is without having to go into every single detail of understanding it. And I think that when all of these plans are coming together, I think having some really honest conversations about what it is and being really upfront about what the risks are and putting that on the table and saying, if this dam were to fail, this is what we would do. What is the worst case scenario? If there was an earthquake, this is what we would do. And to having those conversations and having the community to really leveling the power of being part of those planning processes and really having a clear understanding of what the risks are, and for the community to ultimately to say, you know what, that's acceptable, this is not acceptable, how can we come together on this if this is how we're going to move forward? Because mining is really simple and really complex at the same time. It's, there's a lot of different things, and I think that slowing the process down so it's manageable for people to fully understand is a really important piece. Because what we've experienced in our territory is that the industry, I mean, they're professionals, they're pros, this is what they do, they know this stuff inside and out, so they can go very quickly. But a community who's just learning about all of these processes, not so much. Not everybody's a geochemist, not everybody is a hydrologist. It takes time to understand this in a really fulsome way, and to be able to have those hard scenarios up front to say, let's talk about that. How would we deal with that? What would you do with that? So that you're not having a company propose something up front and then have it countered by somebody, and then you're drawn out and going back and forth. It's like coming together in a way, like we talk about responsible mining, the responsible approach that we like to promote where I come from is to say, well, let's have these conversations before anything gets decided. So that saves everybody time and money. That saves everybody, the grief of trying to resolve it in court, because that's always a lose-lose situation for everyone. So I think trying to steer away from going down the 30,000-page report and then trying to counter it, I think if we can get away from that model, that's moving forward for everybody in a more positive and open way.
Thank you.
I also just wanted to add to that in terms of how does the public digest a wealth of information. And this happens actually every year at Greens Creek when Greens Creek submits its annual reporting on water quality monitoring, biological monitoring, geochemical monitoring. That's a lot of information that I don't think you really would expect anybody to be able to go through and digest. And so annually, the mine gets together with regulatory agencies and interested parties to go through that and give summaries of that and highlight the key aspects of that monitoring. It's an open forum. People are able to ask questions. And I've been doing that for over 20 years, and just trying to provide my technical expertise, my understanding, and get that information out to the interested parties. So that's one aspect, and then also, shifted to Kendra too. That CSP2 is really good at trying to help the public understand this more complex scientific stuff. So I think credit to them, and then also transparency. Just really trying to get that information out there. So just want to add that.
Thank you. Jim, I have one question here on the numbers. Your slide said the average miner makes $110,000 a year. The Department of Labor states the median income for a mine equipment operator is about $49,000 a year. Would local operators expect to make $110,000 or $49,000? Please explain the difference.
Be happy to. Most of the mine equipment operators in Alaska are the guys that are up the highway operating excavators, loaders at the community quarry, gravel quarry, hard rock quarry where rock is being crushed and used for construction purposes. That's what most of that wage number that you're referring to in the Department of Labor's data set. That's very, very different than a metal mine equipment operator. As you look at data like that, it's really important to understand that typically hourly wage rates or even monthly wage data for occupations in the mining industry not only may include occupations that are outside the metal mining industry, but also may typically fail to capture all of the overtime that's typically associated with the mining job. These are, again, can be 2 weeks on and a week off, and will be 11 or 12-hour day shifts, so lots and lots of overtime that will take that $25 an hour job and make it a $40 an hour job and long hours. And it's also important to note that mines, when operating profitably, will also have production bonuses that they provide to the workforce that can elevate that annual average wage. I can say with certainty that a brand new person stepping into the mine without any particular mining experience, working underground, for example, in a bull gang, which is a general sort of a maintenance jack of all trades position. First year miner will be making somewhere in the neighborhood of $75,000 to $80,000 a year, and then that will rise as if they continue to be employed and take on new responsibilities and eventually move into other higher paid positions. So that clearly there are people in the mining industry that are captured in that $110,000 average that are making $180,000 a mine manager, but the rank and file worker is in that $90,000 to $100,000 range, and a fair number there also well above that. As I noted, the average at Pogo, I think, is about 137. Again, lots of overtime, production bonuses, and other things that raise that annual salary above what you might deduce from an hourly rate or even a monthly wage.
Thanks, Jim. I think this one's for Kyle. So who ensures that local, independent, and citizen-based monitoring is done and baseline data is collected to offer a counterpoint to mining industry data?
Can you read the question again?
Yeah, sure, no problem. Who ensures that local, independent, and citizen-based monitoring is done and baseline data is collected to offer a counterpoint to mining industry data?
Well, I'm trying to just answer the question, not editorialize too much, but I think, so therefore the answer I would give to that question is the local, independent, citizen-based groups that have the capacity to monitor would ensure that be done. Especially with that last part about being a counterpoint it sounds like a counterpoint to the baseline data that would be collected either by the state or the mine operator. So I know, I'll leave it at that. It would be the local organizations that have the capacity to do that.
Okay, thanks.
I pulled another, I think a quick question for you, Kyle. Thanks.
Quick ones.
Yeah. We are for hearing from industry that mining regulations are strict, but are there penalties behind these regulations? I would imagine financial, that encouraging mining companies to comply with the regulations.
Excuse me. That was just coincidental that I got choked up there. Yes, it depends on the authorization. I mean, that question could be answered differently depending on what permit you're talking about. Generally speaking, though, very generally speaking, the agencies and the operator want compliance. No operator wants to operate in non-compliance, and certainly no agency wants to allow an operator to operate in non-compliance. And so the goal is always compliance. And how you get there, I personally don't think is that important. How you gain compliance or maintain or achieve compliance is that the fact that you get there. If you get down to what it actually says in specific statutes and regulations at the state level, there are monetary penalties that can be placed. There can be schedule penalties, meaning that a schedule of compliance can be established where there's strict benchmarks that the operator has to meet within a given period of time to be on the path towards an ultimate compliance. And then ultimately, permits can be withdrawn. That's, I guess, the heavy hammer, if you will. If compliance is persisting and there is little effective effort on the part of the operator to regain compliance, the biggest hammer we have is to issue a stop work order essentially on the operation, and that's a huge economic and social license impact to the operator if they cannot perform their operation that generates their revenue. So that's the biggest hammer, I guess, we always have.
Okay, thanks. Okay, this one I think is for Joe. Or Pete, sorry. Who Joe is. Joe, are you out there? You can't answer. Hey, made you all laugh. Okay. What mines anywhere in the world, but in the world, not the universe, do you think are similar to the terrain and hydrology, not necessarily the geology as the Palmer project? So they want to know what mines you think are similar to the terrain and hydrology, not necessarily the geology as the Palmer project. Yes.
Yes. It's hard for me to answer just because the terrain and hydrology is again needs to be unique. But I'd say look at the latitude, the maritime. I'm not going to be able to point to a specific mine that is an exact analog. Greens Creek is fairly close in terms of climate. A little bit, but not exact. So obviously it's deeper, more glaciated here, more recently glaciated. So that's going to have an effect. So I'm not going to be able to answer that question to the satisfaction of the question.
Kyle, do you have?
Yeah, I think maybe Kendra might be a good one to talk on this too, but I'm going to, no? Okay. Okay. So I'm not going to be a scientist with this question. I'm going to be just more of a generalist with this question, even though I have a marine biology background. Pete's right. I can't come up with a mine that says, okay, near tidewater on a fish-producing network of streams, that type of stuff. But if you're talking about a mining operation that's happened in Alaska that is upstream from fisheries, the Pogo mine comes to mind. And I think it has some interesting analogies to what a Palmer project might face as far as challenges of balancing mining so that there's no significant impacts to not only fish resources, but fisheries that occur on those fish resources downstream. One example, I guess I would give just really quickly, is that with the Pogo project, that was a huge issue, potential impacts to fisheries in the Good Pasture River that drove mine design with the Pogo project. And so what ultimately was permitted was called an off-channel water treatment system, where the water comes in, it's treated, and it's not discharged directly into the Good Pasture River that would have like a mixing zone. It's discharged into a two-pond system. One pond is open to the Good Pasture, water flows into that pond. The other pond is closed to the Good Pasture river, and the discharge comes in there. The mixing occurs off-channel, not connected to the river, until water quality standards can be met when it's actually released into the river, so there's no mixing zone in the river. That was a design to address that concern, and I think that's maybe a possible analogy here.
Yeah, I actually can't think of anything off the top of my head, but I will go home and look at that because I think that's a really good and interesting question. And I think the areas I'd probably look at first would be Peru and Chile. Chile may be kind of dry, so I think it's some of the terrain.
I would look at Scandinavia as well.
Okay.
But locally, the one that comes closest to terrain would be Kensington. It's on steep terrain. But you still don't have glaciers. You have snowfields, and I guess there's some small glaciers up on the Moselle Mountain. But it doesn't feed into, it feeds into Johnson Creek, not into a major river. So there is no equivalent. There may be some analogies in Scandinavia, but I don't know anything specific.
Thanks, Paul. And Jacinda, you said earlier it's all about water quality. Here's a question. From your perspective, has water quality data ever been taken by an outside party and then made public?
Right now, there's a university that's located right below the lake. So it's right on the Quinnell River, the outlet, which is not very far from where the disaster came down the mountain. And they've been collecting data of their own, doing their own research, and I believe it will be released next year in conjunction with the 4-year anniversary. The company actually approached them to do their water monitoring data, but they wanted to do their own and to keep separate from the company. And the Ministry of Environment, who's in charge of monitoring the water quality, has actually just devolved it to the company, which has a lot of people wondering what's going on. And there have been some people who've done their own samples here and there, but it's very expensive. It's a very expensive process to constantly be monitoring water. So through the university, that's the only third party that we know of who's been monitoring it continuously from day one of the disaster.
Yeah, good point, and Pete brought that up in his presentation too, that the opportunity for partnerships shouldn't be missed. Young students especially are energetic and interested, so great idea. This one's for Jim, and I'm kind of focusing on you because you're leaving, so I'm trying to get the questions in, or maybe we'll be done before you leave, but okay. What are the potential impacts on crime, and I'm assuming in a community, of 300 mostly men, aged 45 years, with a lot of disposable income, moving to a town of 2,500 people? Do you have any information on that?
That's a loaded question. First of all, the model that I presented today had about 150 local people participating in the mine labor force, and the population that would eventually come with them, their spouses and kids, could total about 450 people total. Again, this is different than a construction phase workforce, which could be, transient, temporary workers, largely men. Here for a short while, it has its own set of socioeconomic considerations for the mining company and for the community to think about. Longer term, though, when the mine is in operation, these are our experience in looking at this with other mines, that these are families. Again, out of this 450 people, there could be 100 school-age kids. This may not all be new to the community. Again, to the extent that people that already live here take these jobs, then that wouldn't be 450 additional people, it would be 350 additional people. So by and large, again, this group doesn't have any greater propensity to commit crime or have demands on health care or place pressures on recreation resources or subsistence resources than anyone else in the community might. So there's nothing unique about this demographic. It is unique in that it's a high-income demographic. It's a demographic that's entirely insured generously in terms of health care, so there are benefits in that regard. But again, separating construction phase, temporary workforce, which sometimes can draw people into the community that don't necessarily have work but are arriving sort of speculatively looking for work, that can have one set of implications that's important to consider in terms of public safety and housing and traffic and that sort of thing. Once in operation, it's a very different demographic, and it's not much different than folks that are otherwise in the community, with the exception that they will have incomes that are above the community average.
Okay, thank you. Here's another question for Kyle. Liz, you may have a response to this also, I think. How often are regulators up inspecting the Constantine drill exploration sites?
Okay, so exploration. So during the exploration phase, actually, Liz, why don't you start? I mean, you can probably talk about what inspections have occurred.
There's no, I guess, standard set schedule, and certainly regulators can come at any time that they want to come and inspect something and look at what they want to look at. Because we are on different lands, we do have BLM inspections or DNR inspections or mental health trust inspections. And then the agencies, regardless of the land status, the state agencies like Fish and Game have authority over fish, DEC has authority over water, regardless if it's on federal land or trust land. And so there's kind of a steady stream of regulators coming through in the summer. We do a lot of visits, and they come from different areas of each agency too. So there might be a BLM wildlife specialist that comes, and there's maybe a Fish and Game wildlife specialist that comes. There's a whole variety. We had lots of people there, especially when you're in an active proposal or permit evaluation period, to look at any information that we submit. They want to come and do on-site visits and certainly do their own observations and their own studies in addition to any studies that we have submitted or third-party studies that we've conducted. And then there's visits that are associated with compliance if there's something that we need to be compliant with. And then there's also visits for reclamation is one of the most important ones. And so we have reclamation standards as far as if we're doing road construction and we've disturbed, the ditches, and then we can plant vegetation, and then the regulators will come and say, okay, you've met the reclamation standard of this percentage of growth and this density, and so they'll do their own inspections with that. So back to, I guess, the questions about drilling, that does get inspected regularly, and folks will look at how the drill holes are inspected, how the drill platforms have been reclaimed, and we have certain standards that we've set in place and agreed upon with all the regulatory agencies saying, if you build a drill pad, when we're done, we will do this. And then when they come back, they see, did you do this? Did you remove all of the footings? Did you pick up all the nails? Is everything cleaned up and did what we say we were going to do? So that's part of the process. When we propose a work program is saying how we're going to reclaim something, and the agencies set up their expectations, and then they'll come and inspect it, and they'll hold the bond until we meet that reclamation standard. So there's regular visits by agencies, and so I guess that maybe answers the question.
One quick, are those on a scheduled basis?
They're not.
The only thing I'll add there is that for Greens Creek and Kensington, there is weekly scheduled inspections by either the state or the Forest Service, in that case, the federal agency, during the operation. Right now, Liz mentioned it, the word inspection, you're there to inspect compliance with a permit condition. So I think it's also good context to remind folks that on the federal side, Constantine, the Palmer Project, has a plan of operations approval from BLM, so that's what they would be on the ground inspecting. On the state side, there is a temporary water use authorizations that are issued right now to Constantine. And then the other one is a miscellaneous land use permit. So they have very few state authorizations right now in the exploration phase. So just as context.
What's good context to add? Okay, this is for Pete. I'm just going to read it. Greens Creek EIS predicts peak acid mine drainage in the tailings after 200 years. Who will treat the water?
I think I got that one already.
Did you? Yeah. Okay, I was quite busy picking another question to pick that one up.
Should I answer it again?
Sure. I missed your answer last time.
Okay. So drainage prediction at 200 years suggests that it would be likely that water treatment would be necessary. And then that it's unlikely that that would be acidic drainage. So that's probably an important point to keep in mind. The cover system is designed to not have that happen, and also in terms of the materials that the drainage is percolating through. But nonetheless, water treatment would be expected at 200 years. The cost estimate includes that, and the bond is set so that that fund is properly filled to cover those costs. So it's ultimately Greens Creek is paying for that cost through their bond mechanism, and that's why it's important to get the bond right.
Well, thanks again.
Can I add one thing there?
So Pete's right with what he said. If Hecla or the mine company at any point in time that owns Greens Creek is not meeting their obligations under the authorizations to treat that water. So let's fast forward 200 years from now, whatever company has the project at that point, if they're not able to treat, there would still be a requirement to have that bond in place 200 years from now, assuming laws stay relatively the same. If they don't meet that obligation, the state would then issue them a notice of violation, inform them that they're not meeting their conditions. If they continue to violate their requirements, then we would seize that bond, meaning we would take that bond at that point, and the state has the ability to put that money, which right now is just for that piece of it, the long-term water treatment piece for Greens Creek is about $14 million. We would put that into a trust fund that would be revenue generating, and that's where you get the perpetual piece of that puzzle.
Okay, thanks again. Jacinda, what sorts of guarantees can Constantine provide about any mine, including socioeconomic impacts, environmental stewardship, if they are no longer a mining company? How has this worked with other mines? What did Imperial do? I'm not sure if I thought they were still a mining company, but that's the question.
Sorry, what was the last part of the question?
How has this worked with other mines? And handling socioeconomic and environmental impacts, etc., when they're no longer a mining company.
I'm assuming this is referring to if a junior company is bought out by a larger company, so you have agreements with the one company and then it gets bought by another company, if those agreements will be adhered to. What we've seen in our territory is that there is no assurance for that. So once you're dealing with another company, you're dealing with a different entity. So the way it was explained to me is that we've had this happen in our territory as well with junior exploration companies, that what we had written into our agreement with them was basically an assurance that if they were bought out by another company, that there would be a settlement to us for selling to a larger company. So there'd be a $20 million settlement to our community to make sure that that was like our bond on our agreement with the junior company. And this is really not common. That was something that was really new within our territory, to hold them to the original agreement, because you can imagine how frustrating it is to make an agreement with somebody else buys them out and they don't adhere to the original, agreement that you had said, okay, I will do it if you do it like this, and it gets bought out by somebody bigger who has no such, agreement with you. So that was one tactic that we used, and it is very difficult because, with the companies being traded or bought out or taken over aggressively by a larger company, those are things to consider as well, of how your community is going to protect itself from switching hands and switching operators.
Okay, I haven't heard of that before. That's very interesting. Did you have a short follow-up, Liz?
I guess I'll keep it quick here, but one of the things that I wanted to mention before we all leave for the day is that I'm happy that we're having this conversation so early in the exploration, years before any development is being proposed, and we can take all of these really good ideas and incorporate them into what's going to work for this area. But one thing that hadn't been really mentioned here yet, and it's one thing that I've been studying from other examples around the world, really, is that in addition to reclamation planning now for after the mine is closed and everyone moves on, there's also now social closure planning. And so really anticipating what are those changes going to be, not on the front end of just building up and ramping up into the mine and those changes, but there's now also professionals in social closure planning about how to retrain the workforce, or how to re-engineer our businesses, and how to maybe use some of the new infrastructure that was created as it was transferred from a mine operation into potentially a tourism operation. So there's some really new exciting things happening in the mining industry that I think we can all sort of look into and see what we can apply here.
Okay, thanks, Liz. Yeah, okay. You're slow. Okay. All right, thanks. Okay, I don't think this one's been asked yet, and it's to Jim. I'm just going to read it. people in Haines fish the Chilkat with subsistence permits? You may or may not know, but if you do, what's the economic value of that subsistence resource to Haines? And then third, why is it worth less than a mine when most of the mine profits leave a community, but the value of subsistence stays within Haines 100%? So it's a three-part question, if you can try.
First two questions, the answer is don't know. There hasn't been any socioeconomic baseline work done on, so far as I'm aware, on this project. That's certainly something that would be addressed in due course. You have to remind me of question number 3.
Yeah, no problem. Why is, it's referring back to the subsistence economic value, why is it worth less than a mine when most of the mine profits leave a community, but the value of subsistence stays within Haines 100%? So there's plenty
I guess I wouldn't say that it's necessarily worth less than a mine. I guess I don't accept the premise of the question. Or the objective of this discussion and socioeconomic planning and agreements is to find the maximum benefit for everyone concerned and mitigate the cost for everyone concerned. So again, I'm not quite sure how to answer that question other than that.
Liz?
Just another thing for us, moving forward is there's been a lot of discussion of subsistence use and subsistence values, and just to let everyone know, it is part of the consideration through the NEPA process is subsistence use, and the BLM has been meeting with the village and with the Chilkat Indian Association as well, and we really want to help incorporate that, both traditional knowledge and traditional concerns. And there are subsistence use studies that can be done and traditional land use studies that can be done, and those are all things that we can contemplate moving forward, and it certainly is something that modern exploration does take into consideration.
Okay. This one's undirected, but I read Pete and Kyle into it, I think, and I'll do my best with the question. Are rules for mining behavior written into the government contract, such as monitoring runoff, quality of leach ponds, containment, are those rules replacing the cementing of acid rocks, adding neutralizing rock to tailings, etc.? So is the latter being less emphasized, I think, is what I read into the question over specific requirements and behavior requirements as opposed to.
I'm afraid I might not be smart enough to understand the question. So, can you say it once more?
Requirements such as monitoring runoff and monitoring the quality of leach ponds and containment, the requirements in the contract, if you will, replacing, I guess, the response of the cementing acid rock, adding neutralizing rock to tailings, etc. And if so, how are these enforced? Is that?
Yeah, I apologize. I don't understand the question.
I'll answer it the way I understand it. I don't understand the contract. I'm going to interpret that as a permit. So, again, these are components, the list that you went through, waste rock, acid rock, cementing those things back in underground. I think you could probably describe those as best management practices more generally. And but as far as what requires those to be done, that's again in the permit conditions at the federal, state, and local level. Monitoring is tied to the waste management permit, the Alaska Pollution Discharge Elimination Permit, the reclamation plan approval. All of those and many others have monitoring requirements. Pete mentioned a little bit ago about how Greens Creek does an annual public meeting every year to summarize those annual monitoring reports. That's also a permit condition under their waste management permit and reclamation reclamation plan approval. We require them to go out and make a public summary meeting of that monitoring data. So look to the permits at all 3 levels, federal, state, and local, for those requirements. And those get built through the NEPA process, through the permit review process, and that's how those get derived.
Thank you. I think that gets in, and the question is kind of looking for whether there's an evolution from the prevention to addressing the after effects or the results, perhaps.
That's a really good question. That point you just finished with, because yes, you go back 50 years, and there was far less environmental laws in our country. NEPA that I mentioned earlier, that's the National Environmental Policy Act of 1969. It's really seen as kind of the cornerstone environmental legislation that kicked off the slew of environmental laws that were passed at the federal level in the 70s, Clean Water Act, Clean Air Act, Wilderness Act, all those things. And then the state evolution, for example, our reclamation standard in the state of Alaska was passed by the legislature in 1991. So there was this lag behind the federal laws and the state laws that you can trace all that back to. So today, the laws, federal, state, and many local laws are geared around prevention of acid rock generation, that reaction starting in the first place. The engineering fields have come a long way in how they address engineering challenges with all of these risk factors with mining. 50 years ago, it was mine it out and walk away, and that's the Superfund program that we essentially have. Has a lot of industrial sites like mining and chemical production and other things that are still on the list to be cleaned up.
I guess part of the way I interpreted that was, one is, how are you going to control the source of the contaminants? And the other question is, are you controlling them? So the first is, what are the actual methods? Are you going to put them back in the tunnel? Are you going to put them back in the pit? Are you going to cover it all up? What's the actual method? And that's a waste management permit. And the other is, are you actually, did those methods work? And that's your water quality, your discharge permit, or your stormwater permit, or water quality permits. To say, yeah, I'm monitoring and I'm still in compliance, or I'm monitoring and I'm not in compliance, or worst case, no one's actually checking and I'm not monitoring where and when I should be. So that's that.
Perfectly said. I don't.
Okay, thanks.
Yeah, thank you.
Good. Good you guys working through there.
Yeah.
Appreciate it. Yeah, so this is addressed to an expert geologist. Got a few of them. So listen up, you rockers. The answer about the difference between placer mining and large-scale hard rock mining was not satisfactory from yesterday. Some of you were here, some of you weren't. Please address the differences between hard rock, large-scale hard rock mining and placer mining, and the potential of acid rock drainage, as well as the use of chemicals, and additionally, the difference in sulfide ore bodies in placer deposits, which you'll probably hit as you talk about large-scale hard rock mining and placer mining.
I realized after I answered that question yesterday, I was not very complete on it, so I'm glad I had an opportunity to clarify. Placer mining is looking for mostly gold nuggets that are in gravel that has been eroded off the mountains over millennia. So in general, that gravel is going to contain gold and not much sulfides, because the sulfides have already been weathered away. So although placer mining has a much larger footprint, it has much less chance of producing acid mine drainage, unless it's a very unusual deposit that has lots of sulfides in with gold nuggets. Whereas underground mining, in most cases, and in the cases that would be used for mining here, has a relatively small footprint from the surface, other than the waste rock that comes out, and other than how they deal with the tailings. So compared to, say, an open pit, which has a huge footprint, and even compared to a placer mine, which has a large footprint, because they have to dig through lots and lots of gravel to get to their ore, they'll have a much larger footprint than an underground mine. But an underground mine is exposing sulfide materials, so it does have a higher potential for producing acid mine drainage, unless you find a way to mitigate that.
And then placer doesn't use chemicals to process the ore because they're just pulling out the nuggets. So the processing is the water running over the riffles. I'd say the only, I was going to say, unless they use mercury, there is placer mining, and this has been especially an issue in California and Oregon, maybe not such an issue here yet, but a lot of the areas where they're doing placer mining, especially they're floating these little pumps on little rafts, and it looks really benign, and it's, unless you're disturbing a whole lot of sediment, it's relatively benign, but the sediments are really full of actual liquid mercury that came out of the legacy mines when they were pouring mercury into tunnels to dissolve the gold. And so in some of the areas in California and Oregon, that has been a real issue, because as you disturb that sediment, you just blast out that mercury. It becomes very small particles, and then it actually moves downstream and contaminates larger areas. So that's been a big issue. It's going to be not quite an issue in most of the parts of here, except for they have used mercury in the past.
The only thing I'll add there from a regulatory perspective is that a placer mining operation that chose to use chemicals, it would be managed more like a large mine. They would be required to have a waste management permit, Alaska pollution discharge elimination permit. The permits that we normally associate with large hard rock mining in Alaska would come into play because of that use of chemicals.
Thank you. Real quick.
Real quick. I guess one of the ways I look at things too is if we're going to be mining anywhere around the world, we need to know how we're going to do it. And the question is really about how. And if we're, if the world is consuming copper, most of the copper mines are using it comes from the sulfide mineral, regardless of where you are. And so the question comes down to, is it high grade, is it low grade? Are there opportunities for smaller footprint because it's underground? Is it close to the road networks? There's different ways to produce copper, and that might be another question to ask in those countries.
Thank you. We have a question that I'll call the final question, because it's actually for everybody here at the table, and then Robert included. But and it's a good one, sort of maybe to help wrap up the day on. And before I ask the question, I want to thank everybody who posed questions and wrote them down, and that's what's made the afternoon and the forum go well. The question for the panel: is there political will among present stakeholders for a good neighbor agreement? And if so, who will take the lead in the process? And we could go down the line or start with Rob.
Well, I think that everyone plays a role in taking the lead on that. I think this event here helps to do that. And you've got the three governments, you've got numerous stakeholders, both local and regional. And I know from our part, we certainly want to help help bridge. I think everyone here brings value to the discussion. All the concerns are real concerns. We want to address them and see them addressed. And so I think that we have leaders at all levels that should be engaged and supported to continue these type of dialogues and discussions. So I think the answer's here in the room and in forums like this as we continue to go forward. And I do have to be at the ferry terminal in 4 minutes, so I'm going to ask your indulgence to be excused. And thank you all for a great 2-day event.